In this problem, we're going to look at some recruiting issues that a factory has had and see if they might need to change their recruiting practices. So recruiters have noticed that hires from a certain high school seem to be less honest than normal. They want to make sure before they change the recruiting strategy. Should we stay away from this high school or is this just something we're imagining? So they collect data using an integrity test that has a uh, that's well validated, that's been tested on national averages, and the national average on the test is 10 with a standard deviation of 2. And so we are going to use these as population scores. And they were 16 candidates from the suspect high school that took the test. And here are their scores. And we want to test the hypothesis that the average employee from this high school is less honest, or specifically that they have a lower test on the integrity test than the national average. So our hypothesis, let's state it up here, hypothesis, the average candidate from the high school in question has lower integrity test scores than the national average. Now we could have compared to the national average. We could also could have compared it to all the employees. They could have given the test to all of their employees to see if this was the case. They could have also, rather than giving it to the candidates, they could have tested people that work for the company that went to that high school to see if that was different also. But here, since a lot of those have already been fired for dishonesty, they're going to test the candidates, and we have these scores here. Now, since we have the national population scores, the average score is 10 with a standard deviation of 2, we can use a Z-test to see if this sample is different than the national average. I'm going to go over to the Z-test calculator, and I'm going to copy it and paste it into Control Copy. I'm going to paste it into this problem. Let's put it over here, Control V, and there we have our Z-test calculator. Let's change this to, the variable name is going to be integrity. Now let's copy the data into the calculator. So Shift down arrow, Control Copy. I'm going to paste it over here, Control V. And there I paste that data. We've got n equals 16, so that's correct. Now the population mean, we've got to put that in because there's just already blank numbers in there. So the population mean is 10. That's what people get the average national average on this integrity test is. And the standard deviation is 2. So we can look at the results here. The average, the sample average is 8.56. So that's lower than the 10, which is what the company suspected. But the question is, that statistically significant? Could we just get that by chance, or does it really show that people that in general at that school score less? Well, we look at the Z is minus 2.88. So that's pretty low Z. And we have to decide, is this a one-tailed test or a two-tailed test? So if we look at our hypothesis, it says they had lower test scores. So this is a one-tailed test. One-tailed test. If we had said that they were different, that they simply had different test scores, that would be two-tailed. But since we hypothesized that they had lower integrity scores, or if we had hypothesized higher integrity scores, that makes it a one-tailed test. So the probability is 0.002. So that's quite low. That's less than our 5%. We wouldn't get such low integrity scores just by chance. It would be really rare. So our conclusion is we have let's write our conclusion. A Z-test comparing the average test scores of candidates from one high school. So what did we have here? We have mean equals 8.56 and n equals 16. There were 16 in that sample. Was significantly the Z-test comparing the average test scores of candidates from a high school was significantly different than the national average on the integrity test, and that was mean equals 10, standard deviation equals 2, and we got a Z equals, let's put that in italics, Control I, Z, Control I, space, equals minus 2.88, and let's do the p-value, Control I, P, Control I, italics off, space, equals 0.002, one-tailed test, and close parentheses. That's how we would report that in APA format. So a test comparing the average test scores of candidates from a certain high school. Let's change that to a certain high school. A certain high school. And let's get that over showing. Mean equals 8.56 and n equals 16 was significantly different than the national average on the integrity test, or on an integrity test would be sounds better. Mean equals 10, standard deviation is 2, z equals minus 2.88, p equals 0.002, one-tailed test. All right, and so that's how we would report that. I think we need a period at the end of there to be complete. All right, so that's how we could report this difference, and this could be good evidence that maybe the company should change its recruiting approach. Maybe it should focus on different high schools where they might not have as many honesty problems.